everyone, and welcome to our first real synthesis lab of the semester, synthesizing alum and observing some aluminum chemistry. Alum you can buy. It's used in cooking. Particularly it's used in pickling to make pickles. Also, an interesting thing about alum is it can be recrystallized to make gigantic crystals. This is a crystal about the size of a person's head. You can make even much larger crystals of alum. It crystallizes very well. Let's talk a little bit about some aluminum chemistry. So aluminum, which is used in things like aluminum cans, the two primary sources are bauxite and cryolite. These undergo a very high energy process in order to extract pure aluminum from these minerals. The reason for this is we have to heat these minerals up to their melting point and then electrolyze them. So aluminum is very expensive to produce from the minerals. It requires electrolysis, and that's why in particular the recycling of aluminum, things like aluminum cans, is very important. Don't try to read all of this, just want to show you this is a general guide to chemical synthesis and purification. And this is just to give you some idea of all the things that we do in chemistry. So an investigator, which today would be you, would select to make a target. That target would be alum. The alum, you would go through a process and you would make the products. But for most reactions, you're also going to get byproducts, and so you're going to have to go through some separation. Separation will give you an actual yield, and at the end, for a real reaction in the research lab, we would also verify the purity of it. And so just doing the reaction is only a small part of most chemical reactions. We go in and there's an extensive amount of work that goes into separating any byproducts that form and giving us a good yield, but also with high purity. So let's talk about the specific synthesis we're going to do today now. Our objective is to synthesize the alum, specifically potassium aluminum alum, which has potassium, aluminum, 2 sulfate ions, and then 12 waters of hydration when it forms the crystal. The synthesis is a process by which a desired substance or product is produced from other substances called starting materials by one or more chemical reactions. We start with some starting materials, perform reactions, and at the end, after doing some purification often, we're left with a product. An obvious starting material for the synthesis of alum is a source of aluminum. And you could think about what some other sources might be. Sources for the potassium, sources for the sulfate. How shall we do that? Here's a procedure that we'll do today. You'll weigh approximately 0.5 grams, and again you want to record all of the digits on the balance, so about half a gram of aluminum on the balance. You're going to dissolve that aluminum in 13 milliliters of a 3 molar potassium hydroxide solution. So aluminum foil was the source of aluminum. The KOH is going to be the source of the potassium. Remember that potassium hydroxide solutions are corrosive. You don't want to get them on your skin or on your clothing. You're going to warm the solution on a hot plate until all aluminum is dissolved. And you want to do this in the hood. This is going to be kind of a weird process. At the beginning, even for the first 3 or 4 minutes, it's going to feel like nothing is happening in this reaction. And then all of a sudden it gets to a point, it'll go very rapidly, the reaction will get hot. So you want to sort of slowly fold your aluminum around in there with a glass rod in the solution, and eventually it'll start to go. You're going to cool that solution and filter by a gravity filtration. You're going to keep that solution. At this point, this solution contains this aluminum hydroxide anion and excess potassium hydroxide. And here's a good setup for a gravity filtration. You just have a funnel here. You have your folded piece of filter paper. You would have your solution here that you're going to filter, and you're going to pour it down the steering rod into the funnel, and it will, just by gravity, drip, drip, drip through the funnel, and here at the end you're left with your filtrate. That's what you're going to do your subsequent reaction with. Here's an example. We've taken and added just a bit of blue dye to this so that it's more prominent, so more easy to see. You are pouring it in and just going to let it drip through. Here's one of the ways that you can fold your filter paper. You want to do one fold across, the second fold across that, And then you'll reach your finger in there, and if you put your finger in the right place, you will open it to a cone. And then you will want to pour your liquid in the cone part and have it go down through there and be filtered. So next, after you've finished the filtration, you have a solution, and you're going to add now, once it's cool, you're going to add 22.5 mLs of a 4 molar sodium sulfate solution. You want to add this slowly. The reaction can be quite exothermic if you add it quickly. You want to add this relatively slowly. And also remember that sulfuric acid is very corrosive. Again, you don't want it on your clothing, and you don't want it on your skin. Okay, and this H2SO4 does a few things. It neutralizes the excess potassium hydroxide. It converts the aluminum hydroxide anion into this aluminum hydroxide neutral compound, which precipitates, and then it converts this precipitate to the aluminum +3 cation here with waters attached. And we do this, and then this, as this step happens, this white precipitate dissolves. So you form a white precipitate in the first step, and then the second step gives you something that's soluble, and so that white precipitate dissolves. Finally, we should also notice we talked about the source of potassium, the source of aluminum. The sulfuric acid is also the source of the sulfate for the alum. You're going to cool in an ice bath. Be sure the bath level is as high as the solution. Let the temperature become as low as possible. Now you're going to do a second type of filtration, a vacuum filtration. You have a filter that looks like this, and you're going to find a piece of filter paper that exactly fits across here, which would be directly under this red compound that's shown. And the red is just to distinguish it from the white background. So this would be your white alum crystals on top of the flat filter paper that's in there. This is basically the setup, although in our new building we are a little more sophisticated than this. You want to clamp your filter flask. Your filter flask is going to run into a secondary container, and then that secondary container, called a trap, will attach to a aspirator that's in the wall. We no longer need to use these water aspirators, and either me or your TA can show you how to hook up to the aspirator. But you want to hook up your filter flask, your vacuum filter flask, trap, and hook that into the wall. Okay, it will look similar to this, but it will have a knob here. It'll be on your inside of your hood. We're no longer using the water aspirator. So here's a close-up on what we're going to do with the filter flask. So we have the filter flask, and we have the filter funnel. Filter funnel has this flat area. The filter paper should be cut exactly the right size that it fits inside there. We'll have this filter paper for the vacuum filtration available for you. It sits down there. You want to clamp everything so that nothing falls over. It can help to put a few drops of water on the filter paper to have it adhere. You're going to attach the tubing now directly to the aspirator, so not to the water aspirator, but directly to the one in your hood, and then turn that on. All right, pouring it in there is going to be a similar thing. You want to pour as carefully as possible. Here in this demo, pouring down a glass stir rod to carefully pour it in there. This is just a sort of funny aside about this. So this alum was once thought to be a part of the synthesis for the philosopher's stone. So mercury, cinnabar, pyrites, alum of excellent quality, borax, black pepper, each in one part, are to be kept in a stone bowl, which is to be deposited in a heap of cow dung. After 1 year, a liquid emerges. This liquid is divine as well as flawless, can be compounded with mercury, admixed with pure gold as the seed. So they believe that mercury could be turned into gold, with alum being one important ingredient in that. So as a joke, we say this is why we collect your alum product. Okay, this is just sort of a flowchart version of that. You would have read and done the pre-lab, weigh your material, dissolve it in the warm KOH, allow the reaction to happen, allow it to cool to room temperature. On the filter paper, you want to see if there's residue in the filtrate. If there is residue in the filtrate solids, you want to go back and do a second filtration to get that out. If not, you want to add your sulfuric acid slowly, cool in a nice bath. We haven't found it necessary to heat to reduce the volume, so we'll skip over that. Once we've obtained crystals, we'll do a vacuum filtration, wash and dry. You'll do a wash as a step of this with ethyl alcohol or ethanol, weigh the product and calculate the yield. So here's what we're doing in today's lab, and this is all in your lab manual. Weigh about 1/2 gram of aluminum foil, record all values from the balance. When measuring the potassium hydroxide and sulfuric acid, don't pour extra back in the bottle. Pour down the drain with running water. You want to handle acids and bases with care. Reactions with aluminum and KOH must be done under the hood because it generates hydrogen gas which will catch on fire. Record your observations. Set the hot plate to 150 after adding the sulfuric acid. There are 3 occasions that you must give descriptions using complete sentences. Use the magnifying glass to observe the provided alum crystals and draw them out in detail. Gravity filtration uses large filter paper, and vacuum filtration uses smaller filter paper. Your lab instructors should initial for approval of your vacuum filtration setup. They should approve your crystals for drying and approve the alum sample for dryness before the final weighing. For waste disposal, all liquid waste is rinsed down the drain. Alum crystals are placed in waste beaker in the hood. Filter paper and weigh boats are thrown into the trash. For cleanup, clean glassware before returning to the drawers. And finally, a few tips and tricks. The reaction between aluminum foil and KOH starts off very slowly, but then once it gets going, it reacts quickly and produces a lot of heat. You want to make sure to use the correct filter paper for gravity filtration and vacuum filtration. You want to make sure to clamp the filter flask and trap so they don't tip over during the filtration, losing your product. If you don't see any crystals form after 15 minutes, ask me or your lab instructor for advice. You need to start filtering your alum crystals at least 30 minutes before the end of lab in order to get them dry.